Hello everyone, I'm Chetan and me and Abhishek will be talking about ZigBee and its integration to internet. So let's look at the outline of the talk. We'll briefly start with the problem statement and then look at the ZigBee protocol and different layers in it, and then we'll look at ways how we can connect ZigBee to internet, and then we'll go to the conclusion. So what's the need for ZigBee? Suppose there's a wireless sensor network node and it is implemented in 15.4 MAC and PHY layer, which are industry standards, but it has custom network and application layer. So what happens when this is the case is, if the custom network and application layer are extended to a set of nodes and they implement a common functionality, it's fine. But suppose I have another set of nodes and they have their own network and application layers. At the PHY layer, it's fine. There is interoperability. Even at the MAC layer, it's fine. But when it comes to network and application layer, since both of them implement different protocols, the the nodes cannot communicate. So if I want my sensor network to grow, or if I want them to communicate to different devices, I have to ensure that my network and application layer are same. That's what ZigBee does. ZigBee introduces an protocol for network and application layer. So what this enables is, now at network and application layer also I have interoperability, and even if I have two different set of sensor networks, I can ensure that they can talk and extend their functionality or extend their region of operation, allowing me to have these benefits. Low cost, secure, common network layer ensures reliable and self-healing. Application layer ensures that it is flexible and extendable. And again, since this is a standard, it is easy and inexpensive to deploy. The 15.4 use ensures that it can be used globally, and since the network now can be extended and more nodes can be added, there is integrated intelligence in the network. Now that was about ZigBee. Now if I have a set of nodes and they implement ZigBee network and have my devices like mobile or laptop which are internet connected, suppose I want to access resources in the ZigBee network, I cannot do it because ZigBee is not really connected to internet. Why do we need connection to internet? Because once the resources in a ZigBee network or a wireless sensor network comes into the internet, I can perform tasks like data analytics, machine learning, control the resources through mobile applications, and ensure that it is interoperable by accessing resources through internet. So that was our problem statement. The first one was ensuring interoperability and extending a wireless sensor network through use of common application and network layers. And the second one is how we can connect ZigBee to internet. This is the ZigBee protocol stack. We have the usual PHY, MAC and network layer, and on top of that we have the application layer, which is again divided into three sublayers: the application support sublayer, application framework, and ZigBee device object. Now we'll look at how each of these layers are implemented and their functionality.
ZigBee networks include coordinators, routers, and end devices. A variety of topologies such as star, tree, cluster tree, and mesh are supported. The coordinator starts and controls the network. The coordinator stores information about the network, which includes acting as trust center and being the repository for security keys. Routers are capable of forwarding data and provide backup routes in case of network congestion or device failure. They can connect to the coordinator and other routers and also support child devices. End devices can transmit or receive a message but cannot perform any routing operations. They must be connected to either the coordinator or a router and do not support child devices. Physical layer provides the interface to the physical transmission medium, example, a radio. The PHY layer consists of two layers. The lower frequency PHY layer covers both 868 MHz European band and 915 MHz band used in countries such as US and Australia. The high frequency file layer is used worldwide, which is 2.4 gigahertz. The file layer supports data rate up to 250 kbps. Some of the features of the file layer are activation and deactivation of the radio transceiver, energy detection, link quality indication, channel selection, and clear channel management assessment. The MAC layer is responsible for providing reliable communications between a node and its immediate neighbors. It helps to avoid collisions and improves efficiency. The MAC layer is also responsible for assembling and decomposing data packets and frames. The MAC layer supports two modes, beacon enabled mode and non beacon mode. In beacon enabled mode, beacons are sent at regular intervals to the devices by the coordinator. Whereas in case of non beacon mode, the devices request for the beacons, following which the beacons are sent. Now let us see how data transfer happens in case of beacon enabled mode. If data needs to be transmitted from device coordinator from the device to the coordinator, the beacon is sent from the coordinator to network device, following which data is sent by the network device, which is acknowledged by the coordinator. If data needs to be transmitted from coordinator to the device, the beacon is sent from coordinator to network device, following which data request is sent by the network device, which is acknowledged by the coordinator, and data is sent, which is in turn acknowledged by the device. For data transfer in case of non-beacon mode, if data needs to be transmitted from device to the coordinator, data is sent by the network device, which may be acknowledged by the coordinator. If data needs to be transmitted from coordinator to the device, the data request is sent by the network device, which is acknowledged by the coordinator, and data is sent, which is in turn acknowledged by the device. Here in ZigBee network layer, here S is the source and D is the destination. AODV is used as a routing protocol in order to determine the route from the source to the destination. Each ZigBee router that participates in the relaying of the frames from particular source to a particular destination maintains a routing table entry for the route. This entry as a minimum records both a logical distance to the destination and the address of the next router in the path to the destination. Routes are established on demand using a route discovery process in which originating device broadcasts a route request command and destination device sends back a route reply. Routing table entry is established during the route reply. Once the routing table entries are established, the route may be used at will. Let us consider an example on how the route is determined using AODV. The source floods route request in the network. Reverse paths are formed when a node hears a request. This process continues, and it is to be noted that each node forwards the request only once. Once the destination is reached, the route reply is forwarded via the reverse path. The forward path is used to route data packets. Hierarchical routing and aggregation or aggregator are the possible optimizations. In a device that implements ZigBee feature set, the network addresses are distributed in a hierarchical manner with ZigBee coordinator. Starting with ZigBee coordinator. In this case, the devices with little or no routing capacity have the option of using the address hierarchy to provide a less efficient but usable route. In most wireless embedded networking applications, there is a distinguished device, often called an aggregator, to which every other device in the network must send data on a regular basis. In order to prevent every device in the network from having to discover the aggregator separately. The ZigBee Pro feature set provides a special case of routing discovery in which a single route request broadcast from the aggregator establishes an entry with the aggregator as the destination and the routing tables of every router in that network. Now let's see how a device can join the ZigBee network. Here ZigBee coordinator has a 64-bit PAN ID and every device have 64-bit MAC address. The coordinator assigns a short address to itself and sends a permit joining request. Then the joining device discovers the network by requesting a beacon. Once the beacon is received, the joining device decides which network to join, after which an associate request is sent. The issued response includes an address for the device to use while associated with that network.
Coming to the ZigBee application layer, as we had seen in protocol stack, this is made up of three sublayers. First, the ZigBee application framework. This contains application objects, and application framework defines execution environment for these objects. Let's see what are these application objects. A node can contain up to 240 application objects, and each of these application object implements application or a functionality which is defined by the manufacturer. That is, the manufacturer gets to decide which application object to be implemented, and each of these application object runs standardized application profiles. Let's see what are these application profiles. These are defined by ZigBee standard. So ZigBee has categorized applications into different domains like home automation, commercial building automation, etc. And each of these profiles defines different device types. And for each of this device type, a 16-bit device ID is associated. The functionality of this device type is defined by its clusters. That is, different device types are made up of different clusters, and thus the functionality is decided. Now, what are these clusters? Depending on the functional domain, ZigBee defines different clusters. For example, lighting, HVAC, security, protocols, etc. For lighting, there can be on-off functionality or color functionality or intensity functionality. And for a given cluster, attributes and commands are defined. And since these are defined, it enables standard command messaging interface. So application development can be ensured in a reliable and generic way, so that different vendors or different manufacturers can still communicate among their devices and extend their operation. Now, how does this all fit into the protocol stack? So we got ZigBee cluster library, using which ZigBee application profiles are defined, and these ZigBee application profiles are implemented as endpoints in a certain node. Each endpoint implements a single device type from single application profile. So a node can have up to 240 endpoints, and each of these endpoint implements a single device type from a single application profile. So let's go back to the stack. So we had application objects. Now these application objects are associated with their respective endpoints depending on the device type and the application profile they implement. And each application object is addressed through its corresponding endpoint. Now these endpoints need to communicate with the network layer. To enable this, we have ZigBee application sublayer, which defines interface between the endpoints and the network layer. What this does is it provides common set of data transport service to all endpoints. So along with application sublayer and framework, we have ZigBee device object, which acts as parallel between the network layer and the ZigBee application layer. This is implemented as endpoint 0. The functionality of ZigBee device object is initializing the APS sublayer and the network layer, defining operating mode of device, and discovering the services of different nodes in the network, and also making its services available, and security management.
Here, let's take an example of home heating network. Several end devices like heater control, fan control can connect to a router such as air conditioning thermostat or heating thermostat. In an automated heating network, the coordinator, in this case the timer, provides control for heating thermostats or the lights.
So that was the ZigBee protocol stack till now. Now let's look at how we can connect ZigBee to internet. We have two ways: ZigBee gateway and ZigBee IP. So in a gateway method, we have a ZigBee network made up of different devices in a mesh network, and we have internet. And suppose in a home or a building, we are connected to this internet via a Wi-Fi router or a modem. We introduce a gateway in between the ZigBee network and the Wi-Fi, which communicates with ZigBee devices via 15.4 and with the router modem via Ethernet or 802.11. Now the development of this gateway is defined as a standard in ZigBee, and it is mainly defined according to ZigBee Pro, which is the protocol which we had seen earlier. And this gateway offers both IPv4 and IPv6 connectivity, and it also offers IP RPC protocol definitions like REST, SOAP. Now, one main thing to consider here is the protocol stack for devices in ZigBee network remains same as before we had seen. Whatever protocol stack we had discussed, it remains in this approach. So as we can see here, the protocol stack remains same, but only we now have a gateway which exposes ZigBee nodes towards an IP network. Coming to ZigBee IP. Now the devices in ZigBee network are implemented as 6-LoWPAN network, and to connect to internet we have a ZigBee IP border router in between, and since the devices are IPv6 addressable, they can be directly connected to internet via this. And so now there's no need of gateway, the devices can directly connect to internet. The 6-LoWPAN enables mesh networking and the nodes are IPv6 addressable. The functionality of a border router is to forwarding between IPv6 and 6-LoWPAN, IP configuration of the nodes, multi-hop routing, that is RPL, which is included in 6-LoWPAN, and context sharing. So now for the protocol stack of ZigBee IP, it changes completely. So whatever we had seen before is not applicable now. Only the PHY and MAC layer remain same, but from network layer, 6-LoWPAN is being implemented. So the network layer now is now in RPL or IPv6, and transport layer has to be implemented consisting of TCP, UDP, and the application layer also changes, offering different possibilities like HTTP, QAP, XML, etc. So that was about ZigBee IP. So in conclusion, ZigBee standardizes network and application layer for WSN devices. This standardization allows development of low-cost reliable devices. To connect to internet, there are two ways. We can either use ZigBee Gateway or ZigBee IP. ZigBee Gateway is mainly used for home automation purposes, and currently ZigBee IP is being developed for smart energy applications. So that was it. Thank you.